Sometimes the universe sends us messages, not through words, but through mystery. In 2017, astronomers saw something that would forever change the way we think about our place in the cosmos. A faint, flickering light racing through the solar system faster than anything we'd ever seen. They called it Oumuamua, a Hawaiian word meaning scout or messenger from afar. And perhaps that's exactly what it was. Scene 1. The moment of discovery. It was the 19th of October 2017. Rob Warrick, a researcher using the Pan-STARRS telescope in Hawaii, noticed a strange point of light drifting across the night sky. At first glance, it seemed like just another comet. Nothing unusual. Our solar system is filled with wanderers of ice and rock. But this one was different. It was moving too fast, its orbit too strange. It was as if the object didn't belong here at all. When astronomers traced its path backward, they realized something astonishing. It wasn't orbiting the sun. It was passing through. Oumuamua wasn't born here. It had come from somewhere else. Scene 2. The cosmic ocean. To understand just how extraordinary this was, we need to remember that our solar system isn't isolated. It drifts through the galaxy like a ship sailing an endless cosmic sea. Far beyond Neptune lies the Kuiper Belt, a ring of icy worlds, the remnants of creation. Beyond that, in unimaginable darkness, is the Oort cloud, a vast sphere of frozen comets that stretches halfway to the next star. These frozen travelers sometimes fall inward, nudged by the gravity of passing stars, gracing our skies as comets. But just as we lose some of ours to the galaxy, other stars lose theirs to us. And so, throughout the Milky Way, countless worlds trade these frozen messengers, wanderers cast adrift between suns. Oumuamua was one of them, a relic of another solar system, sailing through the dark for millions, maybe billions of years before it found us. Scene 3. A stranger among worlds. At first, scientists classified it as a comet, C 2017 U1. But it didn't have a tail, no coma, no glow of sublimating ice. So they changed its label, A 2017 U1, for asteroid. But even that didn't fit. Nothing about it made sense. Not its brightness, not its speed, not its trajectory. It wasn't bound by the sun's gravity. Its path was hyperbolic. That meant it would never return. Once it came, it would be gone forever. Scene 4. The shape of a mystery. As telescopes followed its flight, scientists noticed something even stranger. The light reflecting off Oumuamua pulsed every 7 hours, as if the object was tumbling in space. From this flicker, astronomers estimated its shape. Was it a cigar, long and thin like a metallic shard? Or was it a disk, wide and flat like a cosmic sail? We may never know. But either way, it was unlike any object humanity had ever seen. It was small, perhaps just 100 meters across, shiny, 10 times brighter than most comets. And it was tumbling end over end, its motion chaotic, as though it had been spinning for eons in the void. Whatever it wasn't ordinary. Scene 5. The push that shouldn't exist. As Oumuamua asked the sun, astronomers noticed something that broke the rules of physics. It was accelerating. Not much, just a subtle, silent push, like a whisper from the sun itself. But it shouldn't have been happening. Gravity alone couldn't explain it. Solar radiation wasn't enough, and there was no visible outgassing to propel it like we see in comets. Something invisible was pushing it onward. Rob Warrick, the man who first spotted it, said, its motion could not be explained using either a normal solar system asteroid or comet orbit. It was as if the object had a purpose, as if something or someone had built it to move this way. Scene 6. The theories began. The scientific community erupted in debate. Was it natural? Was it artificial? Or was it something entirely new? Two names quickly rose to the center of the argument. Avi Loeb, a professor at Harvard University, and Daryl Seligman, a young researcher from Cornell. Loeb believed Oumuamua could be alien technology, perhaps a light sail, a paper-thin sheet designed to catch starlight, using it to travel between stars. It was the only explanation, he argued, that fit the data. If true, then for the first time in human history, we had evidence not of aliens watching us, but of their technology silently drifting by. Others disagreed. Seligman proposed a more cautious idea. Oumuamua might be made of hydrogen ice, a hydrogen iceberg sublimating invisibly in sunlight, giving it a gentle, unseen thrust. It was a clever theory, but it came with problems. Hydrogen ice, Loeb countered, couldn't survive the heat of interstellar space. It would have evaporated long before reaching us. So the mystery deepened. Scene 7. The dark comet hypothesis. Years later, in 2023, Seligman teamed up with Jennifer Bergner, a researcher from the University of California. Together, they proposed something new, a hybrid between a comet and an asteroid, a dark comet. They suggested that deep within Oumuamua's icy heart, cosmic radiation might have trapped pockets of hydrogen gas. As it neared the sun, those pockets released their pressure, giving the object a faint but measurable push, one invisible to telescopes. It was an elegant answer. Oumuamua wasn't alien, it wasn't ordinary, it was something entirely new. And that's the beauty of science. When faced with the unknown, we invent new ways to understand it. Scene 8. The question that won't go away. Still, not everyone was convinced. Loeb continued to publish papers, defending the alien technology hypothesis. He pointed out how perfectly its motion aligned with a light sail, how its shape and reflectivity matched what engineers might design for interstellar travel. And he asked a question that echoed through the halls of science. What if we're witnessing the debris of a long-gone civilization drifting between the stars? Was Oumuamua a message in a bottle, a relic from an ancient explorer, or simply a new type of cosmic rock? No one could say for certain, because by the time our telescopes found it, it was already leaving. Scene 9. The vanishing light. Just 40 days after its closest approach to the sun, Oumuamua was already 33 million kilometers from Earth, too faint, too fast for even our best instruments to follow. By December 2017, it vanished into the dark, forever out of reach. We had only a few weeks of data and a lifetime of questions. What was it? Where did it come from? And will we ever see another like it again? Oumuamua was gone, but its story and its mystery had only just begun.
In the months that followed Oumuamua's discovery, astronomers around the world were left staring into the void, haunted by the same question: what did we just witness? It wasn't just about what Oumuamua was made of, it was about what it meant. If it was natural, it was the first of its kind. If it was artificial, it might be the most extraordinary discovery in human history. Either way, it reminded us of a truth the universe often whispers, that we still know so little about the world beyond our sun. Scene 1. A world on alert. By late 2017, the world's observatories were racing against time. Oumuamua was fading, and every second counted. Dozens of telescopes, from Hawaii to Chile, from orbiting satellites to ground-based giants, turned their eyes toward this stranger from the stars. They measured its brightness, its color, its spin. They listened for radio signals, just in case. The Breakthrough Listen project, funded by Yuri Milner and backed by Stephen Hawking, aimed its 100-meter radio telescope at Green Bank toward Oumuamua for hours on end. There was silence. No pulses, no messages, no sign of control. But even silence can speak volumes. Maybe it wasn't communicating, because maybe it wasn't alive. Maybe it was a relic, a drifting artifact, forgotten by the civilization that built it. Scene 2. The alien hypothesis. The idea wasn't as far-fetched as it sounded. For decades, scientists and engineers had dreamed of light sails, ultra-thin sheets of reflective material that could ride the momentum of starlight. The concept was elegant. No fuel, no engines, just light itself pushing you forward. Projects like Breakthrough Starshot were already exploring the idea. Tiny spacecraft accelerated by lasers, capable of reaching nearby stars within decades. If humanity could imagine such technology, why couldn't someone else? Oumuamua's acceleration fit perfectly with what a thin light sail might experience near a star. Was it a probe, a fragment of an interstellar beacon, or a derelict craft from a long-dead civilization? Dr. Avi Loeb asked these questions not to sensationalize, but because they mattered. If Oumuamua was technology, it meant we were not the first to sail these cosmic seas. And that realization would change everything. Scene 3. The critics and the controversy. Not everyone agreed. Many in the scientific community felt Loeb's theory was premature, that extraordinary claims required extraordinary evidence. They argued that natural explanations, however rare or exotic, should come first. Astrophysicist Karen Meech, who led much of the early research, urged caution. It's exciting, yes, but we can't jump to aliens every time we find something new. Still, others admired Loeb's courage to question convention, because throughout history, every breakthrough began with a moment of doubt. Whether or not Oumuamua was alien, it forced us to confront how little we understood about interstellar debris, the ancient flotsam drifting between stars. Scene 4. The next visitor, 2I Borisov. 2 years later, in August 2019, a new light appeared in the sky. This one had a tail. It glowed with familiar gas and dust, a true comet. Its orbit, like Oumuamua's, was hyperbolic, a sure sign that it too had come from beyond the solar system. This new visitor was named 2I Borisov, after Gennady Borisov, the amateur astronomer who discovered it. At last, humanity had found a second interstellar traveler, and with it, confirmation that Oumuamua was not alone. Interstellar objects were real. They weren't myths or accidents. They were part of a galactic exchange, worlds sending fragments of themselves across the stars. Oumuamua was just the first we'd noticed. Scene 5. The Interstellar Highway. Scientists now believe that every star system, including ours, constantly ejects debris into interstellar space. During planet formation, gravitational encounters fling rocks, comets, and ice into the void. These pieces drift for eons, sometimes falling into the gravity wells of other systems, like cosmic messages crossing the dark. It means our galaxy isn't static, it's alive, a vast network of exchange and evolution. Each interstellar object carries with it a fragment of another world story. Oumuamua, in that sense, was not an intruder. It was a visitor, a witness to the birth and death of stars we may never see. Scene 6. The chase. But what if we could chase it? What if we didn't just watch interstellar objects pass us by, but followed them into the void? This dream inspired a new idea, the Project Lyra initiative, led by the Initiative for Interstellar Studies, I4IS. Their goal, to send a spacecraft after Oumuamua. It would be the most ambitious pursuit in human history. A probe designed to catch an object already billions of kilometers away, traveling faster than any human craft ever built. By using gravitational assists from Jupiter and a close solar flyby, scientists believe a spacecraft could, in theory, catch up within 20 to 30 years. Such a mission wouldn't just solve one mystery, it could open the door to an entirely new kind of exploration. Because if one visitor came once, more will come again. And next time, we'll be ready. Scene 7. The Cosmic Perspective. Oumuamua reminded us that the universe isn't empty. It's full of stories, stones and shards from forgotten worlds drifting endlessly between the stars. It may take centuries to uncover their secrets, but every observation brings us closer to understanding our place among them. When you gaze up at the night sky, every star you see could have sent a traveler like Oumuamua on a journey toward another sun. And maybe, somewhere out there, someone else is watching one of ours.
By the time you hear these words, Oumuamua is gone, lost to the vastness between the stars. It will never return. It will never send us a message, never reveal what it truly was. All we have left are the echoes it left behind, numbers, light curves, and the memory of a brief, impossible encounter. But sometimes, mystery itself is the gift. Scene 1. The nature of wonder. When Galileo turned his telescope toward the heavens, he saw moons orbiting Jupiter and realized we were not the center of everything. When Hubble saw galaxies beyond our own, he realized our universe was expanding faster than imagination itself. And when we saw Oumuamua for the first time in human history, we looked at something that came from beyond our solar system, a messenger from another sun. It was small, silent, and fleeting, but it rewrote our sense of scale. It reminded us that the story of existence is far bigger than the boundaries of our world. That's what wonder truly is, not knowing, but wanting to know. Scene 2. The search for meaning. There's a quiet symmetry between the stars and the mind. The universe expands endlessly outward, and our consciousness expands endlessly inward. Every time we stare into the dark, we're not just observing the cosmos, we're reflecting ourselves. Oumuamua may have been a rock, or a relic, or something beyond our comprehension. But whatever it was, it made us ask, what else is out there? And what are we becoming capable of seeing? If the universe truly is infinite, then so are the possibilities. And in that vastness, the greatest discovery might not be aliens, but understanding. Scene 3. A thought from the future. Imagine, one day, a spacecraft built by our descendants sailing through the same regions of space where Oumuamua once passed. It carries not only instruments and data, but art, music, and memory. It carries the story of who we were. And somewhere, in another system, another civilization might look up, see a glint of light, and wonder, what was that? In that moment, the circle closes. We become to them what Oumuamua was to us, a fleeting reminder that the universe is not silent. It communicates, just not always in words. Scene 4. The poetry of the unknown. Every mystery in science begins the same way, with awe. We see something we don't understand. We chase it. We fail. We learn. And through that process, we redefine what it means to be human. Oumuamua may never give up its secrets, but that doesn't diminish its value. It was a mirror held up to our curiosity, a cosmic invitation to keep looking, to keep asking why. Because the moment we stop asking, the universe stops expanding within us. Scene 2. The search for meaning. There's a quiet symmetry between the stars and the mind. The universe expands endlessly outward, and our consciousness expands endlessly inward. Every time we stare into the dark, we're not just observing the cosmos, we're reflecting ourselves. Oumuamua may have been a rock, or a relic, or something beyond our comprehension. But whatever it was, it made us ask, what else is out there? And what are we becoming capable of seeing? If the universe truly is infinite, then so are the possibilities. And in that vastness, the greatest discovery might not be aliens, but understanding. Scene 3. A thought from the future. Imagine, one day, a spacecraft built by our descendants sailing through the same regions of space where Oumuamua once passed. It carries not only instruments and data, but art, music, and memory. It carries the story of who we were. And somewhere, in another system, Another civilization might look up, see a glint of light, and wonder, what was that? In that moment, the circle closes. We become to them what Oumuamua was to us, a fleeting reminder that the universe is not silent. It communicates, just not always in words. Scene 4. The poetry of the unknown. Every mystery in science begins the same way, with awe. We see something we don't understand. We chase it. We fail. We learn. And through that process, we redefine what it means to be human. Oumuamua may never give up its secrets, but that doesn't diminish its value. It was a mirror held up to our curiosity, a cosmic invitation to keep looking, to keep asking why. Because the moment we stop asking, the universe stops expanding within us. Scene 5. The legacy of Oumuamua. The legacy of Oumuamua isn't just in its discovery. It's in the change it sparked, the new missions it inspired, the new telescopes designed to catch the next visitor, the questions rekindled in the human spirit. For centuries, we've looked to the sky searching for gods, for home, for meaning. Now we look and realize we are part of it. We are part of it. We are made of the same dust as Oumuamua. We are travelers too, moving through time, through uncertainty, toward whatever lies ahead. Scene 6. Final reflections. So when you look up tonight and see the stars shimmering in the dark, remember this. One of them once sent us a gift, a silent visitor that crossed our path for just 11 days and then disappeared forever. We don't know where it came from. We don't know where it's going. But for a moment in time, our stories intertwined. And maybe that's enough. Because sometimes the greatest discoveries aren't about what we find, but what they awaken inside us. The universe may not be watching us, but it invites us to keep watching it, to keep wondering, to keep listening. Because the next great mystery is already on its way.